These tabs are open. I'm going to lose my place. All right, so let me go back to just I started recording. The temperature is measured in Celsius. It needs to be changed to Kelvin. We do that by just adding 273. And then there are 4 units of pressure. Now that I changed this so that this looks right. So I just mentioned the torr, and at STP it gets a 760. There's 3 more. So we have Kelvin. These are degrees Celsius plus 273. I normally don't do the degree sign. Then we have 760 torr. But there's 3 other pressures since I gave you the torr. What were they? We were just doing them yesterday. Boyle's law. Okay, that's the other 761, 760 millimeters of mercury. And then there's 2 more. Atmosphere. That's the one I like to use if I get a choice. 1 atmosphere, and then the other one's a kilopascal. And that is, what is that number? Ooh. 101.3. Okay, so just like with boils, if they don't give you a specific pressure and they just say standard temperature and pressure, you can choose one. I would recommend choosing the atmosphere. But if they give you a specific pressure unit, then the other one has to match it. And if both of your pressure units don't match that are provided, then you gotta make them so that they are the same thing. So you have multiple pressures that you can be in. The temperature has to be in Kelvin or this math does not work. And then we will have a work day tomorrow. So you've got, these are your 4 pressures. This is how you change from Celsius to Kelvin. It has to be in Kelvin. Kelvin. And I give you the answers. Oh, look, I forgot to animate. Oh, well, it's okay. It's no big deal. It's supposed to be 4. I changed it because really, these are the same thing. Torr, millimeter of mercury are both 760. So that's normally the one that I've ignored. In all the years that I've taught chemistry, this is the first year I've ever taught torr. But I mean, they're the same thing.
Okay, what's temperature scale is using that one?
Kelvin.
How do you convert this to? Okay.
So this is the third of 4 different parts that are in notes 42. We did Charles' law for 42A. We did Boyle's law for 42B. 42C today is Gay-Lussac, and then not tomorrow, Monday, we're going to smush them all together for the combined law, which I've had it on the board. You literally take the 3 little laws and you smush them together because the combined law can calculate any of them. Because if something is constant, in this case, the volume is constant. Did I not put an equal sign right there? Dang it. Let me freeze this and fix it. Did not put an equal sign. Let me create a text box. Put an equal sign. And drag it where it belongs. I hate Google Slides with a passion. Go up there. You can see me trying to move my thing. You guys can't. All right, so it's not in a perfect spot, but it's good enough. So we've got pressure. So it can be any of these. Now, when we do the, not the combined gas law, when we do the ideal gas law on Wednesday, it has to be in atmospheres. Like, you don't have a choice. If it's not in atmospheres, you need to get it into atmospheres because I'm not going to teach you all of the rate constants. It's going to be easier for you to just get it into atmospheres if it's not there. And that way there's only 1 rate constant you have to know and there's not 4 of them. So it is the pressure and the temperature. The volume is not changing. So this would be a situation where it might say it's in a rigid container because it can't expand or contract. Some situations they can expand or contract. Volume is constant. There is no V on here whatsoever, so there won't be any liters on this problem. Once again, if it ever says that something is constant, it is not in your math. And with Charles' law, there was no pressure. In Boyle's law, there is no temperature. And with Gay-Lussac, there is no volume. But with the combined gas law, it's all of it. With the ideal gas law, it brings in the number of moles of gas. And I could possibly have you balance an equation to get that value. So all that stuff that we did like a while ago, it may come back to haunt you. Like I said, the lady that does your CBAs, I don't know what she's gonna put on there. You don't know until you take it. They don't let us see it. So these are the 4 different pressures that are at standard temperature and pressure. I don't know if I put it on here, but your temperature, something's not right there. There we go. So you add 273 to get it to Kelvin. I'm going to change the way that this looks too, because I don't like that. I yanked these from notes from multiple years ago, and I do not like that. So at standard pressure and temperature, it's technically 20 degrees Celsius, which is 293 Kelvin. Let me put this up the right way. What do I get for not running through this before I show it to you? So technically, if it says it's at standard temperature, and that's all it tells you, it doesn't give you a Celsius, standard temperature is 20 degrees Celsius, which is 68 degrees Fahrenheit, about the temperature of this room. If they only give you that, and they do not give you a number to add to, it is 20 plus 273, which is 293 Kelvin. I don't think they're going to do that on a unit test for this, which would be not next Tuesday, but the Tuesday after. But at least I can see that one before you guys take it. And I always generate my reviews so that they sort of match. I mean, it's not the exact same problem, but it's the same mathematics that you have to do. And this should be a very, very, very heavy math test, just like the last stoichiometry one. So if it just says standard temperature and pressure, if they give you a change to pressure, then you have to make a match. If you can pick, I would recommend using the atmosphere just because it's easier. If it just says standard temperature, it should be 293 K. Otherwise, if they give you a temperature, you need to add 273. So it just depends. It depends on what the problem tells you. Pressure conversions. We've already done these. Okay, they're all equal to each other. If you need to convert, they're a one-step conversion cross. So if you're starting with, and I know they can't see me writing on the board, but let's say you're starting with, I don't know. Let's say you have 842 millimeters of mercury. I'm just pulling a number out of my head. And let's say I want to change it to, now if I'm changing it to torr, you're not doing anything. You're just changing the unit because it's a 1-to-1 conversion. But let's say I want to change this to kilopascals for millimeters of mercury. This is your conversion factor, where the kilopascals gets 101.3 and the millimeters of mercury will get a 760. I don't think I was mean to you like that on this paper, but I haven't even done a review yet because I was busy trying to get the module together for next week on my break. Just your pressures have to match.
I have more 6 weeks.
In this 6 weeks? No. We have, hold on. This is,
The 4th 6 weeks.
I know it is, but there's 7 weeks to 6 weeks. So we have 3 more besides this week, right? So we've got, let me double check. Let me look at the calendar. So let's see, where are we at? We are, so we have the week of the 12th. So we have next week. Asynchronous day is next Friday. Yes, and then we have 2 more weeks after that. So there are 3 more
Next
weeks.
week we have a Friday off.
It's an asynchronous day on Friday. We're up here for a half day. We have to take attendance. No,
Next Friday.
next Friday, the 2nd. For us, we're trying to make back time for the bad weather day, and we still have put in for a waiver for the other 3 days that were missed, and we haven't heard. I don't see why they wouldn't, but anyway, so
That's like next week we have
Friday, the 2nd, which is Good Friday, which a lot of us are not happy that we're having to come on Good Friday. But anyway, so if you're switching, whatever you're starting with, you would drop that unit and what you're trying to switch it into. And once again, they can't see me pointing. These numbers, they come from right here because they're all equal to each other. So it just depends. If you're going from kilopascals to millimeters of mercury, then it's the opposite of this one that I did on the board. If you're going from torr to atmospheres, it would be the same as going from millimeters of mercury to atmospheres because that 760 is the same. And then these blanks are just whatever you're starting with. If your pressure units do not match, your math is not going to be right. If you don't get it into Kelvin and you try doing it in Celsius, your answer is not going to be right. Let me see, let me take a look at mine. Like I said, I haven't made a key. I know I've got old keys somewhere over there, but I'm not digging through all my binders. I'm sorry, I don't know. I apologize. So. We're not gonna die this weekend.
I gotta go to six hours.
I gotta go to work.
So,
Homework.
But it really helps you.
What?
I have.
I've been through.
Oh, we're moving there. Really? When are you moving to Utah?
Like August.
Oh, for next year. We're in Utah. Some of Utah is like really ugly, but our stuff really pretty.
I know it's near Salt Lake City, so that's where my family is, and that's where we is. But it's, I don't know, it starts with the O, I think.
Oh. I don't know.
What's wrong?
Let's see, so 323. Okay, is there anybody that,
You guys see anything?
You know,
that's wrong, but
What's your phone?
okay, I wasn't in the class, so I didn't understand what to do.
oh, obvious. So
Just said it on the. When you say something.
293 times 137. So looks like I have a typo on my answers. Hold on, I may have had fat fingers here too. Mathematical. Looks like I have a typo. I'll fix it. But that's not uncommon for me to have when I give answers if I'm in a rush and I'm off by just a little bit. All right, so we're already at the problem. Like I said, the individual notes on gas laws are unbelievably short. The hardest part is figuring out, is it a 1 or a 2? Okay, so the gas left in a used aerosol can is at a pressure of 103 kilopascals at 25 degrees Celsius. That is going to be my first set. But you have to remember, you have to add 273 to get kelvins. Then we're going to be stupid and we're going to throw it in the fire. And we want to know what the pressure of the gas is inside the can when the temperature reaches, that's a really hot fire.
Is it
928 degrees Celsius.
Is it a brand new fever? I've done it twice.
You can explode and pieces of metal can go straight through your body.
That's
That's
all I
crazy.
know.
So I went camping with my granddad and my cousins, whatever. And me and my cousin made a fire. And my cousin's brother, my other cousin, decided to put his soup in the fire and it exploded because he forgot about it.
Yeah, that's not good.
I put a soda in the fire.
All right, so you just need to put things where they belong.
My mom yelled at me.
I don't know if okay, good, I put the equal sign there. I forgot it on the previous slide. So 103 kilopascals is gonna go here. That means my answer is also gonna be in kilopascals because I need to match. Temperature 1 is 298 and temperature 2 is 1,201. So all I did was plug everything in. And I know it's gonna show up on my hand, okay? But when I block this, I know it's on my hand drill. You would multiply the ones that are diagonal and divide by the one that's left out. That's how you do a proportion. So cross multiply the ones that are diagonal to each other, which is 103 and the 1,201. Divide it by the 298. Your kelvins are going to cancel. Your unit is now going to be in kilopascals. And then I just rounded it to 3/6. Let me check something real quick. I'm waiting. I need to check my online attendance and I need to look something up real quick. I can't type. Yeah, I need to change my, let me go into my thing and change something because I put a typo on my Gay-Lussac's law answer. Supposed to be, the second one's supposed to be 0.33, not 0.31. I just caught it. Like I said, I'm just now making I used the wrong number in here.
Why do you have to add 273?
Because it has to be in Kelvin, and that's how you switch it from Celsius to Kelvin. It's just how we do it. 40 plus 273.
So you have to put it in unit hours of pressure?
Yes, there you have to match. So let's make sure I didn't make a boo-boo on this one. Good how these typos, if I wasn't spending all my freaking free time building airspace science. Okay, number 3 is okay. Okay, now I know some of you might still be writing, but yes, your pressure units are gonna be the same. So if this was millimeters of mercury, then the answer would be in millimeters of mercury. You cannot do your math in Celsius. You have to add 273 to get to Kelvin. And if it just says standard temperature, and that's what I made the mistake with number 2, it says, what is the pressure at standard temperature? Well, standard temperature is 293 Kelvin. It's room temperature. It's 20 degrees Celsius plus 273. And somehow I punched a wrong number when I was originally making my key. I just changed it like on my digital copy, but the answer for number 2 should be 0.33, not 0.31 atmospheres. That's my bad. I just fixed it. But are there questions how I plug this in, or possibly if you're not getting the right answer? I swear I don't make mistakes on purpose. But it's okay. We all learn from our mistakes. You learn more from your mistakes than you do from doing things right. Yeah. Well, we have these giant frontal lobes is to solve problems. Are there any questions at all with this one? Everybody still need another second to write stuff down.
Jordan, you writing this down? Huh? Are you writing this down?
You are?
No.
With an invisible pencil? Uh-huh.
You're watching me.
You do realize this is like some of the easiest stuff, like mathematically, that we do all year.
That's why you failed this class.
I mean, now if your algebraic rearranging skills need help, then that's why we keep having all this extra time after notes and work days. I mean, you just need to figure out like what you were taught wrong, and then how are we going to fix it? Like I said, there are multiple ways to do math problems. You just have to figure out the way that works for you. So I can't stand the teachers that say, you have to do it this way or it's wrong, because there's different ways to do math. All right, so we have a closed container and the pressure is changed. Now here, the from number is the 1 and the to number is the second situation. So that means that the 15 atmosphere is going to be P1, the atmosphere matches, so I don't have to convert. P2 is going to be 16. Once again, the from value is the original, which is the number 1. The to value is the final, which is the number 2. The original, so this means the first temperature was 25 degrees Celsius. You just have to add 273. And we do not know T2. So the answer is going to be in Kelvin. If I asked you for the temperature in Celsius, then once you get that, you would subtract 273. Because that's how you go back and forth. So it will be still the same formula. It'll be 15 over 298, and I would not leave off units. So 15 atmospheres over 298 Kelvin equals 16 atmospheres over T2. Plug everything in. So I'm going to multiply the 298K and the 16 ATM, and then I'm going to divide it by 15. And the atmospheres will cancel out, and I am left with the Kelvin as a unit. And so it's 318 Kelvin if I ask you what it is in Celsius, because there are times when we ask you to change it back. When you subtract 273, it's 45 degrees Celsius. This is exactly the same thing that you were doing with the first, not with a partial pressure, but Charles' law. It's a proportion, but instead of it being volume and temperature, it's pressure and temperature. Still have to get it in Kelvin. Still have,
Wait, what is happening?
the math has to be done in Kelvin
Why?
because it doesn't work with Celsius. Okay, so the reason why that we put it in Kelvin is because Kelvin cannot go underneath 0. You cannot have a negative temperature with Kelvin, but you can with Celsius. And that messes with all of the numbers with the gas law math. So we do measure in Celsius. There's no such thing as a Kelvin thermometer. There's a Celsius thermometer. It used to be called centigrade back in the day. We don't call it that anymore. But the math, you can't have negatives with this. So they change it into the Kelvin scale. You cannot go below 0 Kelvin. That means 0 motion. That means electrons literally freeze and do not move around the nucleus of an atom. It is no energy. It is the absence of motion, which doesn't really exist, but it's an absolute value. It's how we fix the math.
Wait, hold on. This is
What part?
how are you dividing by 15?
These are diagonal. This is left alone. So these are multiplication and that is division. Do you, here, I'll show you. Let me show you. Okay, you're one that probably needs to see the algebra. Every year, no matter which science math class I teach. So 15, 298K. Okay, so this is what it originally was. I don't want this in the denominator. So I'm going to multiply this to both sides to get it out. And I don't want this in the denominator. So I'm going to multiply it over here to get it out. So the first thing you would do is 15.0 times your temperature. Okay, and that gets it off the bottom. What I had on the right was already this. And I want to get this off the bottom. So I'm going to make it linear by doing it this way. Now I want this alone by itself. So I'm going to divide both sides by 15 because that's the opposite function of the multiplication.
Wait, why have to subtract them?
You don't, because it's the opposite of multiplication. It's not added, it's multiplied.
No, for the answer.
Oh, because I took it out of Kelvin and put it in Celsius.
So you have to do
Only if I ask specifically for it in Celsius, otherwise you can leave it in Kelvin.
Wait.
But that's how you get from there to there.
Did you put it on the pen? The thing?
On the assignment,
Yeah.
I'm still making my key. I like I said, I'm trying to get ahead for a change so I can do something with my kid this weekend. So we go from 323.0K to 273.15K. So far, I haven't come across it, but I've only gotten to number 4.
My shoulders are sore.
That's tough.
On the front, no. And like I said, the only typo that I've caught with the answer is number 2 should not be 0.31 atmospheres. It should be 0.33. I don't know what I did when I have not used that paper in years. So who knows? Who knows what was going on in my head when I made the mistake? Like I said, I promise I don't do them on purpose. And then